Hello students, welcome back to computer science class. I am Mangala, lecturer in computer science, Vidyarashmi Vidyalaya, Savanur. In last session, we were discussing about the chapter typical configuration of computer system, and we have seen the definition of the motherboard, the types of motherboard and the components of the motherboard. And let's discuss about the next topic, that is memory. In computer system, we can store the data and instruction where the place called memory. So, memory is nothing but it is a computer memory, refers to the electronic storing space for data and instruction. So, in memory we can store the data and instruction for a temporary or the permanent basis, which the computer will use that data and instruction in its operations. So, computer memory alli we can store the data matte instruction annu navu store ಮಾಡ್ತೇವೆ. Depends on it's a temporarily or a permanently. So, there are two kinds of memory. First one is internal memory and second one is external memory. Two types of memories are internal memory and external memory. Let's see one by one. So, the memory is just like a human brain where we can store the data and instructions. So, this is about the internal memory. What is internal memory? It refers to the memory that stores small amounts of data that can be accessed quickly while the computer is running. Internal memory refers to memory that stores small amount of data that can be accessed quickly while the computer is running. Computer run ಆಗ್ತಾ ಇರುವಾಗ it may request data or the information. That time the data will be accessed quickly, which is stored in the memory by the computer. So, internal memory includes registers, cache memory and primary memory. Internal memory mainly includes registers, cache memory and primary memory, which are directly accessed by the processor. So, some of the features of the internal memory are: it is a temporary storage memory. Data will be stored temporarily in the internal memory, and limited storage capacity. As we know that it stores only a small amount of data, so that's why it is having limited storage capacity. And fast access. Whenever the computer requests the data, memory allows the computer to access the data quickly. So, it is called as a fast access. Next is high cost. The cost of this internal memory is very high. So, features of the internal memory is: it is a temporary memory and it is having only the limited storage capacity, and it gives fast access to the computer, and it is high cost. Next we see about registers. What is registers? Registers are refers to the high speed storage unit within the CPU. Registers are high speed storage unit within the CPU. So, and it is a temporary storage area for holding the data and instruction under the direction of a control unit. The data and instructions are stored in the registers temporarily, and it is a temporary storage area for holding the data and instruction under the direction of a control unit. So, whenever the computer requests the instruction and data, or whenever the computer gets the instruction and data, it will send that instruction and data to the registers for the processing. And the number of registers used in CPU and size of each registers are affect the power and speed of the CPU. The register size ಅಂದರೆ ಎಷ್ಟು ನಾವು ರಿಜಿಸ್ಟರ್ಸನ್ನು ಯೂಸ್ ಮಾಡ್ತೇವೋ ಅಷ್ಟು ನಮ್ಮ ಕಂಪ್ಯೂಟರ್ನ ಸ್ಪೀಡನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ಬೋದು. ರೆಜಿಸ್ಟರ್ಸ್ ಇದು ಸೈಜ್ ಎಷ್ಟು ಜಾಸ್ತಿ ಇದೆಯೋ ಅಷ್ಟೊಂದು ನಾವು ನಮ್ಮ ಕಂಪ್ಯೂಟರ್ನ ಸ್ಪೀಡನ್ನು ಜಾಸ್ತಿ ಮಾಡ್ಬೋದು. ಸೊ ರೆಜಿಸ್ಟರ್ಸ್ ಆರ್ high speed storage unit within the computer, within the CPU, and it is a temporary storage area for holding the data and instructions. So whenever it gets the data or instructions from the cache or RAM, it will directly send the data and instruction to the registers for the processing, and the number of registers used in the CPU and the size of the registers affect the power and speed of the CPU. ಸಿಪಿಯುನ ಪವರ್ ಸ್ಪೀಡನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತದೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ವಿ ವಿಲ್ ಸಿ ಕ್ಯಾಶ್ ಮೆಮೊರಿ. Cache memory is a high speed memory available inside the CPU to speed up the access of data and instruction which is stored in RAM memory. So cache memory is a high speed memory which speed up the CPU. It is which will use to speed up the access of data instruction which is stored in the RAM memory. So it will reduce the average memory access time. Cache memory we can store the some of the data and instruction which is regularly used. So whenever the CPU requires or ask the data or instruction, it will first check in cache memory whether the data and instructions are present in cache memory or not. If it is there, then it will directly use the data and instruction from the cache memory, otherwise it will look into RAM. So it will reduce the average memory access time. ನಾವು ರೆಗ್ಯುಲರ್ ಆಗಿ ಯೂಸ್ ಮಾಡುವ ಡೇಟಾ ಆ್ಯಂಡ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸನ್ನು ಯಾವಾಗಲೂ ಕ್ಯಾಶ್ ಮೆಮೊರಿಯಲ್ಲಿ ಸೇವ್ ಆಗಿ ಇರ್ತದೆ. ಸೊ ಸಿ ಪಿ ಯು ಯಾವಾಗ ಡೇಟಾ ಮತ್ತು ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ರಿಕ್ವೆಸ್ಟ್ ಮಾಡ್ತದೋ ಆವಾಗ ಫಸ್ಟ್ ಇಟ್ ವಿಲ್ ಚೆಕ್ ಕ್ಯಾಶ್ ಮೆಮೊರಿಯನ್ನು ಚೆಕ್ ಮಾಡ್ತದೆ. ಆ ರಿಕ್ವೆಸ್ಟೆಡ್ ಡೇಟಾ ಆ್ಯಂಡ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಕ್ಯಾಶ್ ಮೆಮೊರಿಯಲ್ಲಿ ಇದೆಯಾ ಅಥವಾ ಇಲ್ಲ ಅಂತ. ಎಲ್ಲಿಯಾದರೂ ಇದ್ದರೆ ಅದು ಡೇಟಾ ಮತ್ತು ಇನ್ಸ್ಟ್ರಕ್ಷನನ್ನು ಡೈರೆಕ್ಟಾಗಿ ಕ್ಯಾಶ್ ಮೆಮೊರಿಯಿಂದ ಯೂಸ್ ಮಾಡ್ತದೆ. ಇಲ್ಲದಿದ್ದರೆ ಅದು ರ್ಯಾಮಲ್ಲಿ ನೋಡ್ತದೆ ಆ ಡೇಟಾ ಮತ್ತು ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ರ್ಯಾಮಲ್ಲಿ ಉಂಟಾ ಇಲ್ವಾ ಅಂತ. So it will reduce the average memory access time. That's why it is called as, it will speed up the access of data and instruction which is stored in the RAM memory. So it stores the program that can be executed within a short period of time. Within a short period, ನಾವು ರೆಗ್ಯುಲರ್ ಆಗಿ ಯೂಸ್ ಮಾಡುವಂತಹ ಡೇಟಾ ಆಗಿರ್ಬೋದು ಅಥವಾ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಆಗಿರ್ಬೋದು, that will be stored in the cache memory. The CPU has a built-in level 1 cache, level 2 cache and level 3 cache. CPU has a built-in ಯಾವುದೆಲ್ಲ level 1 cache, level 2 cache and level 3 cache. Level 1 cache it is present within the processor ಇದು ಅಲ್ಲಿ ಪ್ರೆಸೆಂಟ್ ಇರ್ತದೆ. ಆ್ಯಂಡ್ ವೈಲ್ ಕಮಿಂಗ್ ಟು ಲೆವೆಲ್ 2 ಕ್ಯಾಚ್, ಇಟ್ ಈಸ್ ಬಿಟ್ವೀನ್ ದಿ ರ್ಯಾಮ್ ಆ್ಯಂಡ್ ಸಿ ಪಿ ಯು. ರ್ಯಾಮ್ ಮತ್ತು ಸಿ ಪಿ ಯುನ ಮಿಡ್ಲಲ್ಲಿ ಇದು ಲೆವೆಲ್ 2 ಕ್ಯಾಚ್ ಇರ್ತದೆ. ದ ಸೈಜ್ ಆಫ್ ದಿ ಲೆವೆಲ್ 1 ಕ್ಯಾಚ್ ಈಸ್ 256 KB ಆ್ಯಂಡ್ ಲೆವೆಲ್ 2 ಕ್ಯಾಚ್ ಈಸ್ 6 MB. ಆ್ಯಂಡ್ ಲಾಸ್ಟ್ ಒನ್ ಈಸ್ ಲೆವೆಲ್ 3 ಕ್ಯಾಚ್ ವಿಚ್ ಈಸ್ ಅ ಸಪ್ರೇಟ್ ಕ್ಯಾಚ್ chip. So it is a built-in, it is a separate cache chip. So what happened is, for example, ನೀವೀಗ ಆಫೀಸಲ್ಲಿ ವರ್ಕ್ ಮಾಡ್ತಿರುವಾಗ you will be provided one desk. So in that desk you will keep some of the, so we call it as a RAM, and that desk which contains drawers, we call it as a cache memory. So whenever ನಿಮಗೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಫೈಲ್ ಕ್ಯಾಶಲ್ಲಿ ಏನಾಗಿರ್ತದೆ, ನೀವು ರೆಗ್ಯುಲರ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿರುವಂತಹ ಏನು ಫೈಲ್ಸ್ ಆಗಿರ್ಬೋದು ಅಥವಾ ಪೆನ್ಸ್, ಸ್ಟೇಪ್ಲರ್, ಏನಾದರೂ ರೆಗ್ಯುಲರ್ ಆಗಿ ಯೂಸ್ ಮಾಡುವಂತಹ ಥಿಂಗ್ಸನ್ನು ನೀವು ಕ್ಯಾಶಲ್ಲಿ ಅಂದರೆ ಡವರಲ್ಲಿ ಇಟ್ಟಿರ್ತೀರಿ. ನೆಕ್ಸ್ಟ್ ಏನಂದರೆ ಟೇಬಲ್ ಮೇಲೆ, ದಟ್ ಈಸ್ ರಾಮ್, ನಿಮಗೆ ಎಷ್ಟೊಂದು ಫೈಲ್ಸನ್ನು ಇಡ್ಲಿಕ್ಕಾಗ್ತದೋ ಅಷ್ಟೊಂದು ಫೈಲ್ಸನ್ನು ಇಟ್ಟಿರ್ತೀರಿ. ಸೊ ನಿಮಗೆ ಫಸ್ಟು ಈಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಫೈಲನ್ನು ವರ್ಕ್ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಪೆನ್ ನಿಮಗೆ ಬೇಕಾದರೆ ನೀವು ಡ್ರಾವರನ್ನು ಚೆಕ್ ಮಾಡ್ತೀರಿ. ಆವಾಗ ಡ್ರೈವರಲ್ಲಿ ಇರ್ತದೆ. ಇಲ್ಲದಿದ್ದರೆ ನೀವು ಬ್ಯಾಕ್ ಆಫೀಸಿಂದ ನೀವು ಆ ಫೈಲ್ಸ್ ಆಗಿರ್ಬೋದು, ಏನಾದರೂ ನೀವು ನಿಮಗೆ ಬೇಕಾಗಿರುವಂತಹದ್ದು ಫೈಲ್ಸನ್ನು ಬ್ಯಾಕ್ ಆಫೀಸಿಂದ ನೀವು ತರಿಸಬೇಕಾಗ್ತದೆ. ಸೊ ನಿಮಗೆ ಬೇಗನೆ ಸಿಗಬೇಕು, ಹಾಗೆ ನೀವು ಕ್ಯಾಶಲ್ಲಿ ಅದನ್ನು ಸ್ಟೋರ್ ಮಾಡಿ ಇಟ್ಟಿರ್ತೀವಿ. ಸೊ this is about the cache memory. Cache memory is a high speed memory which is available inside the CPU to speed up the access of data instructions which is stored in the RAM memory, and it reduces the average memory access time. Also it stores the program that can be executed within a short period of time, and it has some built-in cache, that is level 1 cache, level 2 cache and level 3 cache. The size of the level 1 cache is 256 KB and level 2 cache is 6 MB and level 3 cache is 12 MB. Next is primary memory. Primary memory is a computer memory that a processor or computer accesses directly. It is a computer memory that a processor or a computer access directly. Direct ಆಗಿ ಇದನ್ನು access ಮಾಡಬಹುದು for the requesting of any data or the instructions. So primary memory is faster compared to the secondary memory. Why? Because it is a internal memory, that's why the primary memory is faster which compared to the secondary memory. The data and instructions are stored internally. So the primary memory is faster which compared to the secondary memory, and it consists of random access memory and read only memory. Primary memory consists of random access memory, two types of memory, that is random access memory and read only memory. So the primary memory is a computer memory that a processor and computer access directly, and it is faster than a secondary memory because it is a internal memory. Without the primary memory we cannot use computer, and it consists of random access memory as well as read only memory. So next, what is secondary memory? Secondary memory refers, it holds the programs and data which are kept on a long term basis. In secondary memory we can keep the programs or we can store the programs and data for the long term basis, and it is a permanent memory. Example for secondary memory are hard disk, floppy disk, magnetic disk and flash drives. In secondary memory programs and data are kept on a long term basis, and some of the examples for secondary memory are hard disk, floppy disk, magnetic disk and flash drives. Next we see RAM. RAM stands for random access memory. RAM stands for random access memory. So the RAM is also called as main memory of the computer system. Random access memory, it is also called as the main memory of the computer system, and it is also called as the temporary memory because the information which is stored in this memory are lost whenever the power supply to the computer or laptop which is turned off. ನಮಗೆ ಕಂಪ್ಯೂಟರ್ನ ಪವರ್ ಸಪ್ಲೈ ಯಾವಾಗ ಆಫ್ ಆಗ್ತದೋ ಆವಾಗ ಡೇಟಾ ಆ್ಯಂಡ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ವಿಲ್ ಬಿ ಲಾಸ್ಟ್. ಸೊ ದ್ಯಾಟ್ಸ್ ವೈ ಇಟ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ volatile memory. And the types of RAM are SRAM, DRAM, SDRAM and DDR SDRAM. SRAM means static RAM, DRAM means dynamic RAM, SDRAM means synchronous dynamic RAM and DDR SDRAM means double data rate SDRAM. RAM is nothing but random access memory which is also called as the main memory of the computer, and it is a temporary memory because the information which is stored in this memory are lost when the power supply to the computer or laptop is switched off. That's why it is a volatile memory. The information will be erased from the memory when the power supply is turned off. The types of RAMs are SRAM, DRAM, SDRAM, DDR, SDRAM. Let's see one by one. DRAM. DRAM stands for dynamic RAM. It is the most common type of memory chip and it is cheaper and consume less power. DRAM is very cheap while comparing to SRAM and it consumes less power. It must be refreshed continuously to store information, otherwise it will lose what it is holding. So, DRAM continuously, it must refresh itself continuously because to store the information, otherwise it will lose what it is holding. DRAM continuous ಆಗಿ ನಾವು ಅದನ್ನು refresh ಮಾಡ್ತಾ ಇರಬೇಕು, otherwise it will lose the data or information which it is holding. For example, ನೀವು continuous ಆಗಿ ಓದ್ತಾ ಇರ್ತೀರಿ, ಒಂದು 4 hours ಅಥವಾ 5 hours ಓದ್ತಾ ಇರ್ತೀರಿ, ಆವಾಗ ನಿಮಗೆ ಮಿಡ್ಲಲ್ಲಿ ಬ್ರೇಕ್ ಬೇಕಾಗ್ತದೆ. ಬ್ರೇಕ್ ತಗೊಂಡು ರಿಫ್ರೆಶ್ ಆದಮೇಲೆ ನೆಕ್ಸ್ಟ್ ವಾಪಸ್ ಓದ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಿ, ಆವಾಗ ನಿಮ್ಮ ಬ್ರೈನಿಗೆ ಜಾಸ್ತಿ ಪ್ರೆಷರ್ ಬೀಳೋದಿಲ್ಲ. ಅದೇ ರೀತಿ ಇಲ್ಲಿ ಏನು DRAM ಇಟ್ ಮಸ್ಟ್ ಬಿ ರಿಫ್ರೆಶ್ಡ್ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಟು ಸ್ಟೋರ್ ದಿ ಇನ್ಫಾರ್ಮೇಷನ್, ಅದರ್ವೈಸ್ ಇಟ್ ವಿಲ್ ಲೂಸ್ ವಾಟ್ ಇಟ್ ಈಸ್ ಹೋಲ್ಡಿಂಗ್. ಆ್ಯಂಡ್ this refreshing operation occurs automatically thousands of time per second. ಇದು ರಿಫ್ರೆಶಿಂಗ್ ಏನು ಆಟೋಮ್ಯಾಟಿಕ್ ಆಗಿ ಟೇಕ್ ಪ್ಲೇಸ್ ಆಗ್ತದೆ, ಲೈಕ್ ಥೌಸಂಡ್ಸ್ ಆಫ್ ಟೈಮ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್. ಒಂದು ಸೆಕೆಂಡಿಗೆ ಥೌಸಂಡ್ಸ್ ಆಫ್ ಟೈಮ್ ಇದು DRAM ರಿಫ್ರೆಶ್ ಆಗ್ತಾ ಇರ್ತದೆ. ದ್ಯಾಟ್ಸ್ ವೈ ಬಿಕಾಸ್ ಆಫ್ ಇಟ್ DRAM ಈಸ್ ಸ್ಲೋ. ಇದು ಪ್ರತಿಯೊಂದು ಇನ್ಸ್ಟ್ರಕ್ಷನಿಗೂ ಅಂದರೆ ಪರ್ ಸೆಕೆಂಡಿಗೆ ಒಂದು ಥೌಸಂಡ್ಸ್ ಆಫ್ ಟೈಮ್ಸ್ ಇದು ರಿಫ್ರೆಶ್ ಆಗ್ತಾ ಇರಬೇಕು ಟು ಸ್ಟೋರ್ ದಿ ಡೇಟಾ. ದ್ಯಾಟ್ಸ್ ವೈ ಇದು DRAM ಈಸ್ very slow. So, the DRAM is a dynamic RAM and it is cheaper and consumes less power and it must be refreshed continuously to store the information, otherwise it will lose the data which it is holding. And refreshing operation occurs automatically like thousands of times per second, and because of this DRAM is slow. That is about DRAM. Next we see SRAM. SRAM is nothing but static RAM. SRAM is nothing but static RAM. It is used in cache memory due to its high speed. SRAM is a very high speed memory, so because of it, it is used in the cache memory and it does not need constant refreshing. While in DRAM it needs a constant refreshing for the storing of data, otherwise it will lose. But in case of SRAM it does not need constant refreshing and that's why SRAM is faster compared to the DRAM. And in SRAM it is expensive than DRAM and it takes up more space in a chip. So, compared to DRAM, SRAM is expensive and it takes up more space in chip because these memory cells are having more parts. That's why it takes more space than the DRAM and it stores the information as long as power supply is there. As long as you power supply is supplied, the information will be stored as long as the power is there. So, SRAM is nothing but it is a static RAM and it is used in cache memory due to its high speed and it does not need constant refreshing. It does not need constant refreshing while comparing to the DRAM, and it is expensive than DRAM and it takes up more space in chip. It is expensive than DRAM and it takes more space because because in DRAM it is made up of different parts. So, it stores the information as long as the power supply is there, and compared to DRAM, SRAM is faster. Next type of RAM is SDRAM. SDRAM stands for synchronous dynamic RAM. Here what happens is, it is a special type of DRAM that synchronized to the system clock. SDRAM is a special type of DRAM that is synchronized to the system clock. The special thing is it knows when the next cycle is coming and has data ready when the CPU requests it. It knows when the next cycle is coming. Next cycle ಯಾವಾಗ ಬರ್ತದೆ ಅಂತ ಇದಕ್ಕೆ ಮೊದಲೇ ಗೊತ್ತಾಗ್ತದೆ and has the data ready when the CPU requests it. ಅದಕ್ಕೆ ಬೇಕಾಗುವಂತಹ ಡೇಟಾ ಅಥವಾ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಅನ್ನು ರೆಡಿ ಮಾಡಿ ಇಟ್ಕೊಳ್ತದೆ when CPU request it. CPU ಯಾವಾಗ ರಿಕ್ವೆಸ್ಟ್ ಮಾಡ್ತದೋ ಆವಾಗ ಆ ಡೇಟಾವನ್ನು ಅದಕ್ಕೆ ಬೇಕಾಗುವಂತಹ ಡೇಟಾವನ್ನು ಅದು ಪ್ರೊವೈಡ್ ಮಾಡ್ತದೆ. So it knows when the next cycle is coming and has the data ready when the CPU requests it. That's why it increases the efficiency by reducing the CPU waiting time. Already ಇದು ಡೇಟಾವನ್ನು ರೆಡಿಯಾಗಿ ಇಟ್ಕೊಂಡಿರ್ತದೆ. ಸೊ ದ CPUಗೆ ವೇಟ್ ಮಾಡಬೇಕಾಗಿಲ್ಲ. ಸೊ ಇಟ್ ವಿಲ್ reduce the CPU waiting time and also it will increase the efficiency of the CPU. ಅದರ ಎಫಿಷಿಯನ್ಸಿಯನ್ನು increase ಮಾಡ್ತದೆ. So SDRAM is nothing but it is a synchronous dynamic RAM and it is a special type of DRAM that synchronized to the system clock and it knows when the next cycle is coming and has the data ready when the CPU requests it. That's why it will increase the efficiency as well as the efficiency by reducing the CPU waiting time. And the last one is DDR-SDRAM. DDR-SDRAM nothing but double data rate SDRAM. Here it works same as the way as the SDRAM. Andre it knows when the next cycle is coming and it has the data ready when the CPU requests for it. So same way SDRAM ಹೇಗೆ ವರ್ಕ್ ಮಾಡ್ತದೋ ಹಾಗೆ DDR-SDRAM ವರ್ಕ್ ಮಾಡ್ತದೆ. and ಬಟ್ ಏನಾಗ್ತದೆ ಅಂದರೆ ಆ್ಯಸ್ ದ ನೇಮ್ ಟೆಲ್ಸ್ DDR ಅಂದರೆ ಡಬಲ್ ಡೇಟಾ ರೇಟ್. ಇಲ್ಲಿ ಡೇಟಾ ಟ್ರಾನ್ಸ್ಫರ್ ರೇಟ್ ಈಸ್ ಡಬಲ್. ಇಲ್ಲಿ ಸಿಂಗಲ್ ಆಗಿದ್ದರೆ ಇಲ್ಲಿ ಡಬಲ್ ಅಂದರೆ ಎರಡರಷ್ಟು ಜಾಸ್ತಿ ಡೇಟಾವನ್ನು ಇಲ್ಲಿ DDR-SDRAM ಪ್ರೊವೈಡ್ ಮಾಡ್ತದೆ. ಸೊ DDR-SDRAM is a double data rate SDRAM. It works same as the SDRAM that it knows when the next cycle is coming and get the data ready when the CPU requests for it. But here the data transfer rate is double. So these are the types of the RAM. First one is static RAM, dynamic RAM, synchronous dynamic RAM, and last one is double data rate SDRAM. The next topic is power supply to a computer system. So the electric power is the main source of supply for a operation of electronic components of a computer. The computer na electronic components correct agi work ಮಾಡಬೇಕಾದ್ರೆ the electric power supply ಇರಬೇಕು. ಈವನ್ ಕಂಪ್ಯೂಟರಲ್ಲಿ ವರ್ಕ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಪವರ್ ಸಪ್ಲೈಯನ್ನು ಅದಕ್ಕೆ ಕಂಪ್ಯೂಟರಿಗೆ ಕೊಡಬೇಕು. ಇಲ್ಲದಿದ್ದರೆ ವಿ ಕ್ಯಾನಾಟ್ ಯೂಸ್ ಕಂಪ್ಯೂಟರ್. ಇಟ್ಸ್ ಲೈಕ್ ಅ ಬಾಕ್ಸ್. ಸೊ ಎನಿ ಟೈಪ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಡಿವೈಸ್ it requires electrical power to do some task or operate it. There are two types of power supply connected to a computer system. Computer system ge two types of power supply annu ನಾವು connect ಮಾಡಬಹುದು. First one is SMPS. SMPS nothing but switch mode power supply, and the another one is UPS, that is uninterruptible power supply. Let's see what happens in SMPS. Here it is a high efficiency and are widely used in a variety of electronic equipments. It provides high efficiency to the computer and also are highly widely used in a variety of electronic equipments, variety of ಅಂದರೆ ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಇಕ್ವಿಪ್ಮೆಂಟ್ಸ್ ಇರ್ಬೋದು. ಅದರಲ್ಲೆಲ್ಲ ನಾವು ಯಾವ ರೀತಿಯ ಪವರ್ ಸಪ್ಲೈ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದರೆ ಸ್ವಿಚ್ ಮೋಡ್ ಪವರ್ ಸಪ್ಲೈಯನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಇಟ್ ಗಿವ್ಸ್ ಅ ಹೈ ಎಫಿಷಿಯನ್ಸಿ ಟು ದಿ equipment, also are widely used in a variety of electronic equipments. Here what happens is it converts AC power from electrical outlet to the DC power needed by the system components. Idu AC power from electrical outlet, AC power annu DC power ige convert ಮಾಡ್ತದೆ. DC power which is needed by the system components. System components ಗೆ ಯಾವುದು DC power ಬೇಕಾಗಿರ್ತದೆ. ಅದು ಸೊ ಮೇಯ್ನ್ ಆಗಿ AC power ಇರ್ತದೆ, ಅದನ್ನು DC ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿ ಸಿಸ್ಟಮ್ ಕಾಂಪೋನೆಂಟ್ಸಿಗೆ ಅದು ಪ್ರೊವೈಡ್ ಮಾಡ್ತದೆ. ಸೊ SMPS is a switch mode power supply which provides high efficiency. Also it is widely used in a variety of electronic equipments, and it converts AC power from electrical outlet to the DC power needed by the system components. And the next type of power supply is UPS, that is uninterruptible power supply. UPS which includes battery to maintain power in the event of power failure. UPS ಏನು ಒಂದು ಬ್ಯಾಟ್ರಿಯನ್ನು ಹೋಲ್ಡ್ ಮಾಡಿರ್ತದೆ, ವಿಚ್ ಇನ್ಕ್ಲೂಡ್ಸ್ ಬ್ಯಾಟ್ರಿ. ಇದರಲ್ಲಿ ಏನು ನಾವು ಪವರನ್ನು ಕರೆಂಟನ್ನು ಸ್ಟೋರ್ ಮಾಡ್ಬೋದು. ಆ್ಯಂಡ್ ಇನ್ ದಿ ಇವೆಂಟ್ ಆಫ್ ಪವರ್ ಫೇಲಿಯರ್ ಅಂದರೆ ಯಾವಾಗ ಪವರ್ ಸಪ್ಲೈ ಇರೋದಿಲ್ವೋ, ಮೇಯ್ನ್ ಪವರ್ ಸಪ್ಲೈ ಇರೋದಿಲ್ವೋ ಆವಾಗ ಕಂಪ್ಯೂಟರ್ ಬ್ಯಾಟ್ರಿಯಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿರುವ ಪವರನ್ನು ಕರೆಂಟನ್ನು ಯೂಸ್ ಮಾಡಿ ವರ್ಕ್ ಮಾಡ್ತದೆ. ಸೊ ಇನ್ UPS it includes battery to maintain power in the event of power failure. Here there are mainly two types of UPS. First one is online UPS and the second one is standby or offline UPS. In online UPS ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, it continuously provides a power from its own inverter even when the power line is functioning properly. In online UPS it will continuously provide the power supply to the computer even when the main power line is functioning properly. ಅಂದರೆ ಇದು ಇನ್ವರ್ಟರ್ ಆಗಿ ವರ್ಕ್ ಮಾಡ್ತದೆ. ಫಂಕ್ಷನ್ ಆಫ್ ದಿಸ್ ಈಸ್ ಲೈಕ್ ಇನ್ವರ್ಟರ್. ನಮ್ಮ ಮನೆಯಲ್ಲಿ ಇನ್ವರ್ಟರ್ ಇರ್ಬೋದು, ಇನ್ವರ್ಟರಿಂದ ನಮಗೆ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಪವರ್ ಸಪ್ಲೈ ಆಗ್ತಾ ಇರ್ತದೆ. ಕರೆಂಟ್ ಇದ್ದರೆ ಕೂಡ ನಾವು ದಟ್ ಮೇನ್ ಪವರ್ ಲೈನ್ ಈಸ್ ಇನ್ವರ್ಟರಿಗೆ ಬಂದು ಅಲ್ಲಿಂದನೇ ನಾವು ಇದು ಎಲ್ಲ ಇಕ್ವಿಪ್ಮೆಂಟ್ಸನ್ನು ನಾವು ಯೂಸ್ ಮಾಡುವಂಥದ್ದು. ಸೊ online UPS continuously provides a power from its own inverter even when the power line is functioning properly. And the next type is standby or offline UPS. Here it monitors the power line and switches to battery power as soon as it detects a problem. It will monitors the power line. Power line ಅನ್ನು ಅದು ಮಾನಿಟರ್ ಅಂದರೆ ನೋಡ್ತಿರ್ತದೆ, ಚೆಕ್ ಮಾಡ್ತಾ ಇರ್ತದೆ ವೆದರ್ there is a power or not, and switches to battery power as soon as it detects problem. As soon as ಇದಕ್ಕೆ ಪ್ರಾಬ್ಲಮ್ ಏನಾದರೂ ಕಾಣಿಸ್ಕೊಂಡ್ರೆ ಅಂದರೆ ಪವರ್ ಫೇಲಿಯರ್ ಆದರೆ ಅದು ಮೇನ್ ಪವರ್ ಲೈನಿಂದ ಅದು ಏನು ಸ್ವಿಚಸ್ ಟು ಬ್ಯಾಟ್ರಿ ಪವರನ್ನು ಅದು ಯೂಸ್ ಮಾಡ್ತದೆ. ಸೊ ಸ್ವಿಚಿಂಗ್ ಬಿಟ್ವೀನ್ ದಿ power line to battery, it will take several milliseconds. That time the computer will not getting any power. So there are two types of power supplies. First one is switch mode power supply and second one is uninterruptible power supply. In SMPS it provides high efficiency and are widely used in a variety of electronic equipments, and it converts AC power from electrical outlet to the DC power DC power which is needed by the system components. And uninterruptible power supply which includes a battery to maintain power in the event of a power failure. And there are two types of UPS. First one is online UPS, which continuously provides a power from its own inverter even when the power line is functioning properly. And in standby or offline UPS, it monitors the power line and switches to battery power as soon as it detects some problem. So this is about the power supply to a computer system. The last topic of this chapter is assembling the computer system. So the computer configuration is the process of setting up your hardware devices and assigning resources to them so that they work together without any problem. ಅಂದರೆ ಕಾನ್ಫಿಗರೇಷನ್ ಮಾಡುವಂಥದ್ದು ಕಂಪ್ಯೂಟರನ್ನು, ಅಸೆಂಬ್ಲಿಂಗ್ ದಿ ಕಂಪ್ಯೂಟರ್ ಸಿಸ್ಟಮ್, ಎಲ್ಲ ಕಾಂಪೊನೆಂಟ್ಸನ್ನು ಕರೆಕ್ಟಾಗಿ ಅದಕ್ಕೆ ಬೇಕಾಗುವಂತಹ ರಿಸೋರ್ಸನ್ನು ಪ್ರೊವೈಡ್ ಮಾಡಿ ಕಾನ್ಫಿಗರೇಷನ್ ಮಾಡುವಂಥದ್ದು. The computer configuration is the process of setting up your hardware devices and assigning resources to them. ಎಲ್ಲ ಹಾರ್ಡ್ವೇರ್ ಡಿವೈಸಸ್ಸನ್ನು ಸೆಟಪ್ ಮಾಡಿ ಅದಕ್ಕೆ ಬೇಕಾಗುವಂತಹ ರಿಸೋರ್ಸಸ್ಸನ್ನು ಪ್ರೊವೈಡ್ ಮಾಡುವಂಥದ್ದು. ಇನ್ ಕೇಸ್ ದ ಕಾನ್ಫಿಗರೇಷನ್ ಕರೆಕ್ಟಾಗಿ ಆಗಿಲ್ಲದಿದ್ದರೆ ಯು ವಿಲ್ ಗೆಟ್ ಎರರ್ಸ್. ನೀವೇನಾದರೂ ವರ್ಕ್ ಮಾಡ್ತಾ ಇರುವಾಗ ನಿಮಗೆ ಎರರ್ಸ್ ಬರ್ತದೆ. ಸೊ ಕರೆಕ್ಟಾಗಿ ಕಂಪ್ಯೂಟ್ರಲ್ಲಿ ವರ್ಕ್ ಮಾಡಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಅದರ್ವೈಸ್ ಕಾನ್ಫಿಗರೇಷನ್ ಕರೆಕ್ಟಾಗಿ ಆಗಿದ್ದರೆ ಯು ಕ್ಯಾನ್ ಅಪ್ಗ್ರೇಡ್ ಯುವರ್ ಕಂಪ್ಯೂಟರ್ so that you can increase the efficiency of the computer. So this is about the assembling the computer system, and this is the end of this chapter. The weightage of this chapter is 4 marks. 1 mark 1 question and 3 mark 1 question. This is very easy chapter and easily you can score 4 marks. Thank you.